Good afternoon, everyone. It's a privilege to be here with you today and to knowledge share with you and learn about what's happening in this part of the world with respect to BIM and digital construction. My name is Willem. I'm the head of IT and BIM at Rogers, Stirk, Harbour and Partners Architects. We are an international practice who have branches in London, Sydney and Shanghai, with also a couple of scattered satellite offices all over the rest of the world. I'm going to tell a little bit about a project we've worked on, which is a clinical design project. It's called the King's Health Partners Cancer Centre at Guy's. Within our practice, we actually know it simply as the Guy's and St Thomas Cancer Treatment Centre, so I do apologise if I sometimes revert to the previous name of the project. Just to give you a little bit of background on our practice, we are an architectural practice that was founded in 1977. You may also know us as the Richard Rogers Partnership. We're well known for looking at architecture in a slightly different way from a lot of our competitors. We like to celebrate the structure and the services of a building, and often that means that we take the structure and the services and we take it from the inside of the building and we put it in the outside. Lately we've also become a bit more known for experimenting with wood and organic shapes in projects such as the Welsh Assembly Building, which you can see in the bottom right-hand corner there. And BIM for us as a practice isn't completely new, but we haven't delivered many projects which are completely in BIM. The project you see on the left-hand side there, which is the Leadenhall Building in London, otherwise known as the Cheese Grater, is a building that we started working on probably about 11 years ago, and that project would not have been possible had it not been for the use of BIM authoring tools, specifically Bentley Architecture and Bentley Structural. And the steel megaframe would not have been fabricated had it not been for the fact that we use those tools and also management processes alongside those tools to interact with our steel fabricators and the main contractor. But we can't call that a BIM project in earnest because only some aspects of the project actually benefited from BIM tools and processes. A very large portion of that project actually relied on very traditional CAD drawings. The King's Health Partners Cancer Treatment Centre at Guy's was a project that we won in 2010. It was the first project where we had a client who also represented a contractor, I apologise, who also represented the client, who came to us with a very, very clear mandate and goal with what they wanted to get out of building information modelling and management processes. The project in itself is quite interesting. We've previously done a cancer treatment centre that was at a much, much smaller scale. This project has a value of £160 million. It's roughly 28,000 square metres. And the principle of the project design is that the cancer treatment patient goes through a journey where they enter the building on the ground floor into a triple volume, which is a welcome village, and then from there they progress their journey through other welcome villages, which are triple volume, then above that another double volume, and another triple volume. And each of these villages have a different feel with respect to colour, texture, and also the way the public realm and the private realm is demarcated and separated from one another through balustrades that wrap around the building. When the contractor came to us, it was at the end of 2010, they had a very comprehensive set of protocols that they wanted us to adhere to. In fact, there were 27 documents that outlined their requirements for BIM. Now that we've learned quite a lot since we started in 2011, I think it's fair to say that rather than having someone come to us with a BIM execution plan and BIM protocol, we prefer to sit down with a BIM execution plan with the entire design team and evolve that as a collaborative process in itself. I think that saves an immense amount of time, it prevents errors and also risk mitigation downstream. The great thing was this client had a very clear vision of what they wanted to accomplish for BIM. They had a very clear picture of their objectives. Some of the challenges we faced on this project are very similar to project challenges we still face today with respect to BIM. The big issues we had initially was interoperability issues, inconsistencies in file formats, even file formats which are effectively recommended in most regions as being open BIM file formats, and the consistency within those file formats. Different levels of BIM maturity across the design team. So we would work with fabricators who would say we can engage with you using BIM, but different fabricators had different understandings of what that meant. For some fabricators, BIM meant in 2011 that they were using SketchUp for fabrication. Some fabricators in turn used Rhino, some used AutoCAD, and a lot of the fabricators and trades and members of the supply chain didn't have the same level of capability as, let's say, the engineers. The contractor themselves had invested very heavily in BIM tools, processes, training and management processes that link into their entire risk management strategy as an organization. We always say in the office 50 shades of BIM, because when you speak to different people in different regions, it means different things. When we work with some clients in France, they'll come with a very robust understanding of what BIM is, whereas other clients will say, I just want a 3D model, and it won't be used for anything other than exploring the design. Whereas clients on the other end of the scale will come to us and they have a very clear picture of what they want to deliver as a database to hand over to the client, the owner and the operator downstream from the design stages. We also had a lot of problems with misalignment of geospatial information, and that was even when we worked with collaborators who used the exact same platform. So we found it quite challenging to deal with 3 different engineers, all using Autodesk Revit, but in the early stages of the project, none of their models actually lined up. So that was a very tedious process initially, and we only overcame those hurdles when we started hosting design workshops where we actually trained everybody and showed them how the different tools worked and how those tools have to facilitate a very comprehensive, streamlined process, so that it's not just about modeling and delivering information which can be put into a database, but the very basic thing of spatial coordination has to be resolved at the earliest stages possible. Another thing that we found that was very frustrating was there was a disconnect between BIM data, specifically metadata that's input into the models, and specification information. We're now seeing a lot more of that, those problems being solved. But when this project started taking off in 2011, we had one organization preparing the specification, and the contractor anticipated that despite the fact that we as the lead designer, we as the architect, were not responsible for preparing the specification, all of the doors, fire ratings, all of the partitions that we put in a model, all of the floors would always carry the latest version of the specification. Because the specification wasn't linked to the BIM data, that always meant there was a disconnect. And until people doing specifications on our project started linking their information directly to the BIM, that disconnect actually caused a lot of problems, because a lot of risks started occurring. Contractors would link the models into their coordination platform, and on site they would start looking at the model, they'd start interrogating things like doors, and they'd say, well, this has got a fire rating of 2 hours, but the specification said it's 1 hour. And that's where we started getting a lot of risk arising. And that's where we started introducing the principle of what we call lean BIM in the office, where we would start very specifically stripping out all information and geometry, but specifically metadata that wasn't actually required, because someone else would be embedding that specific information downstream. Varying levels of model development, and that encompasses level of detail. In other words, having too much geometric detail in the model is a problem that we're still tackle today. And also a level of information which relates to the previous thing I just mentioned, where we would get models that would have so much information embedded, but the information wasn't relevant to what we were delivering as a design team. Another problem we had was engineering disciplines weren't tracking the architectural lead designer with a high enough frequency. That's a very valuable lesson we learned. Today we try and have design workshops in the office, which are DTMs, basically, design team meetings, which are followed by BIM workshops closely thereafter to make sure that everyone understands the latest changes. We do model reviews with a much higher level of frequency as well, and that way we can ensure that the structural engineer and the mechanical, electrical, plant engineers follow the lead designer's changes much more frequently. Other problems we had back in 2011 was in the UK especially, there was a lot of BIM hype and BIM wash. A lot of people wanted to be seen to be engaging with BIM, engaging with the tools and the processes, and that very much perverted what a lot of companies are trying to accomplish with BIM delivery on big construction projects. Even in a small project like this of just 28,000 square meters, we found that there were a lot of stakeholders engaging in the project who weren't being completely honest about their actual BIM capability. And that gets us to the other I of BIM, which to us as a practice has become very important. And that I is integrity. And we're seeing a lot more integrity in the industry when it comes to people filling in BIM capability statements, people speaking very freely and openly about what they can actually achieve. Because for us, as a practice, we would much rather have someone come to us with a low capability and work with them to uplift their capability so that we know we're going to have the same goal and there's a reality about achieving that goal for the project. At the end of 2010, there was a lot of awareness of what is happening with the UK government and the UK government's BIM task group, and our client was very interested in that. You've seen a lot of my peers here showing talking a lot about level 2, which is a level of maturity in the UK. In fact, the presentation so far has been so good, I thought my presentation can probably just be 5 minutes and then you can all go for coffee. For us, as a practice, this was something that caused a bit of a stir, and I have to admit one of the biggest challenges internally was cultural resistance. When a lot of people started thinking through what it means to have level 2, what it means to adhere to that, I think it caused a bit of confusion, and so we addressed that head-on through education. And one of the great things we have is a very clear diagram of the Great British BIM maturity wedge to help us understand what that means. And here it is. And if you want to understand what that wedge actually means, you should travel to a place in the United Kingdom called Cheddar, and then you can get a better understanding of how we interpret BIM in cheese. The real BIM capability and BIM maturity diagram is this one here, which you've seen previously. And as you can see, the red line represents there on the screen. That's something you probably see in every BIM presentation in the United Kingdom. And just like one of my peers mentioned earlier, it's one of the things that's actually made us question whether BIM is completely overused. The handy thing about this capability diagram, this maturity diagram, is it's something that when we do our intro to BIM courses and modules within our practice, it's something that's very clear to represent the kind of data that we have to create, the standards we have to adhere to, the protocols we have to adhere to, and the common goal we need to have as a practice. But even so, a lot of people in the practice still preferred cheese, and some people didn't like cheese wedges being interpreted as a BIM capability and a BIM deliverable. So that led us to the next topic, our BIM gym. We don't officially call it the BIM gym, it's something we just kind of throw around in the office. But rather than taking our staff into very comprehensive brainwashing sessions, which would last 1 to 2 to 3 days, where effectively they'd be trained in just BIM tools, I developed a BIM, and it's not just a BIM training program, it's effectively a digital design and construction management program which consists of 32 modules. And each module lasts anything from 1 to 2 hours. And we start with a basic understanding of what CAD is, legacy CAD, because as a practice, all our projects are not BIM. We have a lot of projects which are still legacy CAD and 3D and visualization, but can't actually be referred to as true BIM projects. And so we are very, very open and honest about that. 80% of our projects in the office use BIM authoring tools, but that doesn't mean they're BIM projects. It just means they use BIM authoring tools to leverage design, leverage drawing production, leverage schedules, and they certainly don't adhere to full comprehensive BIM level 2. Our training programs in the office run every Tuesday, every Thursday, and for those who want to actually do yoga, we have free yoga lessons every Monday night as well. If you ever come to our office in London, you're more than welcome to join me for a yoga session on a Monday night. The training focuses on BIM tools, BIM processes, giving our staff an understanding of the protocols, because the reality is the staff who have an understanding of it are only those who really work in BIM projects where that is a project requirement. It also focuses on analysis, trying to give the architects an understanding of how we can leverage BIM tools, processes, to understand the design better, do optioneering, understand the impact on the environment, have a look at the impact it's going to have in the public realm. We focus on the best practice drawing production, schedule production, database production methods for us as a practice. That doesn't necessarily mean that's best for other practices. And we are constantly changing that, evolving it, and enhancing it. Some of the processes we use to streamline our BIM workflows are actually very traditional. And some of these processes have been around for probably 15 years or more. But for a lot of architects who come, young architects who come out of university, they can use the tools, but that doesn't mean they understand construction delivery processes and how to get the best out of software meets process, meets construction documentation, meets facilities management downstream. I talked a little bit about a training program. I won't go into the details of that. One of the things that we find very useful is we collect training data, and we actually use that training data in our staff's ongoing skills assessments, and also when we do our staff reviews on an annual basis. We have a review of the training they attended and the training they've missed, so that we can make sure we cover all the holes in their training. This specific project that we worked on was only the second clinical project we ever worked on. The design team that we worked with, I do apologize, consisted of ourselves, Roger Stirk, Harbour and Partners, as the lead designer and the lead architect, who took responsibility for the lower welcome villages of the project, so the entrance village and the ground floor and a portion of the first floor, and also doing the clinical design of that section of the building. The higher levels of the project was done by a different clinical architect called Stirk, Anshin and Allen. And when they started in the project, they were simply called Anshin and Allen, who were a London-based architectural practice. During the project, they were actually bought out by Stirk, and that had some complications introduced into the project, which we tried to address very quickly, because it meant they moved from one software platform to another. So our co-architect initially used ArchiCAD and some AutoCAD, and then they were taken over by a company who effectively mandated the use of Autodesk Revit across the board. So they had a cultural shift, and we tried to absorb that as we worked on the project. We also collaborated very closely with Arab, both structures and mechanical, and with a mechanical and electrical subcontractor called Crown House, who are actually now owned by the main contractor that we worked with on the project. So those were the 6 main chefs who were involved in cooking up the meal, the big dish, that was the guys in St. Thomas Cancer Treatment Centre. On this project we had probably a lot less authoring tools and applications than my peers were talking about here earlier. We are quite a small architectural practice. We only have 200 staff worldwide, and a lot of the people we collaborated with have tens of thousands of staff worldwide. So they came into the project with multiple software platforms. But this is just a basic overview of the key platforms we used on this specific project. The central data environment that is used for this project is one called ASIDE, which is a web collaboration construction portal. And at the time we worked on this specific project, it wasn't so much a true collaboration environment, such as, for example, ProjectWise that some people have referred to. It was more of a web system that you would upload drawings to, you would then download drawings from, you would upload BIMs to, you would download the BIMs again, and people would make comments that they would upload again. That system has now evolved so that it's far more integrated into our local server environment as well, so that the commenting and the design change management can take place in a much smoother manner. One of the applications we used, which was mandated, is an application called Codebook, which specifically facilitates clinical design and is used in hospitals, Ministry of Defence buildings, Ministry of Justice buildings, because it's effectively a tool that plugs into BIM authoring tools and harvests the relevant data for that specific project. So in the instance of a hospital project such as this one, it would specifically focus on harvesting the furniture, fittings and equipment, specifically clinical equipment, because the NHS Trust, who's ultimately the client, who will be the owner and operator of the building, wants to make sure that they can do asset management, asset tracking, and also upgrades to the building in future. And for them, Codebook was a very important piece of software, because effectively the NHS, which is the National Health Service in the United Kingdom, have a database which plugs into Codebook. BIM was something that we benefited from, not just for construction documentation, but also for design analysis, design exploration. So we were able to use our native BIM authoring tool, and sometimes that allowed us to do renders on the fly, renders overnight, renders during office hours. So if we had to do value engineering or optioneering, a perfect example of that would be, for example, the balconies you see wrapping around the building. We had to refine those balconies constantly, so they were really an element that seemed really light and celebrated the core of the building and didn't seem like something that was very heavily impeding on the public realm of the street. This building had very, very tight site constraints. At the back of the building, it had to have a soft link with the existing Guy's and St Thomas Hospital, and this is a 3D printed model that came straight from our BIM data, and the gap between the existing hospital and the new hospital is just 500 millimeters at the back. You can see that gap over here as well. And using BIM as a process of design evolution and refinement allowed us to always keep in check that we coordinated in 3D with not just the other disciplines that were creating new model-based data, but also we help the contractor with issues such as health and safety monitoring and management on site. BIM was a tool that allowed us to explore the potential of design. We are a practice that creates a lot of buildings that are very much like Lego and Meccano. We create buildings that are effectively consisting of a kit of parts. And BIM is something that really lends itself to that process of development. Traditional drawing production is something we still can't quite get away from. On this project, the contractor had a lot of goals and a lot of ambitions with regards to how they anticipated their supply chain might utilize BIM data. In the end, probably only half of the supply chain were able to utilize real BIM data in the form of 3D geometry and database information. We're still trying to get some metrics back from the contractor to try and find out how close that was to their initial goal. A lot of the supply chain, a lot of trades still relied day to day on traditional drawings. And for us, 2D drawings don't always express our design very well. because we take great pride in the little parts of the building, how all of the junctions come together. This made us face all sorts of challenges, because a lot of the younger staff in the practice seem to have an obsession with over-detailing the geometry. The way they work, it seems, is they would zoom in to the nuts and bolts without really grappling with the fact that actually there's a separate data vessel for that. There's a separate data model that can focus on those nuts and bolts and really enhance that so the designers understood. So we had to work very closely with our design team to make sure they understand the value of not over-detailing information. So the information you're seeing here, this geometry comes directly from our architectural BIM, and as you can imagine, there's limitations to the size of projects you can detail to that level. As I mentioned, traditional drawing production is something that we've always done as a practice, and it's something where we always use BIM tools, but we didn't really dig into it very deeply. I'm going to skip forward a little bit. Automatic annotation is something that really changed a lot of the architects' view of BIM, I think, virtually overnight, because they learned two things. A, the annotations take place for them, and B, it's always accurate. That saved them a lot of time and a lot of stress. Having a BIM data model allowed us to also feed information to visualizers. That's something that is really valuable. I was talking a little bit earlier about managing the building as a kit of parts, and by working with building components, it allowed us to manage the building in a very efficient manner. We were able to track changes to specific components, and this has had a great effect in turn on how we train. We don't just train 3D modeling, we train component management, and we're trying to get our architects to think a little bit more about what is the library you need to make your project work for you effectively. This is just another example of that, where we're using automatic extraction and automatic coloring of the facade and its different components to understand what's going to happen in fabrication with the different fabricated modules. And this is a fairly generic example of how we're doing schedule production, specifically in this instance, cladding schedule production. Whereas in the past, in the previous generation of architects in our office, typically the attitude would have been, let's get a first-year student and get them to sit with the drawings and count all of the modules, and then someone else might check that, someone else might double-check that in turn. Having the ability to produce schedules, it's a very basic function of BIM authoring tools, but it's become something that's more of a process of delivery to other people we work with, like the quantity surveyors, like the contractor. And it also helps the architect to visualize the quantities of specific things that they actually put into their building. When it came down to 3D coordination, we had a lot of problems with some of the fabricators, and some of the disciplines had quite a lot of issues with clashes. And rather than just basically engaging with correspondence, where we would say there's a clash here, we started setting up more workshops. Some of these workshops actually meant that we had to take some of the people we collaborate with and train them in-house a little bit, so that we had a very clear understanding of what their capability was. But more than that, not just the capability that they had, the view they had towards the design and the view they had towards delivering BIM. As a practice, we do not employ BIM technicians, BIM technologists, or BIM modelers. We see BIM and the construction delivery processes that link to BIM and the authoring tools as something all of the architects have to learn. There are obviously generational differences that affect this, and so we're trying to see how we can manage our human resources so that some of the architects who might not be that interested in adopting BIM skills are still a valuable asset to us when it comes to checking and validating our information. Just a little bit more about the collaboration process and the coordination process with our engineers. This was probably the first project in our office where in 2011 we started to look very closely at how the different disciplines come together. This is actually a very, very basic example here. We have merely got the architectural model, the structural model, the MEP model, And then when you combine that with the clinical model, that's effectively what you get to give the architect an understanding of how it all comes together.
Mr. Cook, a quick ending, please, okay? We're out of time. Okay.
Thank you. I'm just going to wrap up. Clash avoidance is a typical thing that we use to analyze how our own buildings come together and how it gels with the other disciplines in the project. Just going to skip through these. And one of the things that's really important for us is to make sure the people doing the fabrication for our building have a very clear understanding of what our design intent is. And so if you look at the renders that come straight from the BIM, and I skip forward to what's actually been fabricated on site, our view is that that has really been captured because we've been able to deliver using the BIMs, the building information models, to our different fabricators downstream, and they've been able to interpret the information in the correct fashion. And that's just a very basic example of the architectural steel staircase model on the left and the metal work contractors model on the right-hand side. And although there's been some value engineering, if you look at the top of it, you'll notice some of the glass that we had in the architectural model has been value engineered out. And the great thing about that is it's very easy for us to see if that's been understood clearly. And I'd just like to say thank you very much, Achu. It's been a real privilege to be here. Thank you.